Now that you've got an understanding of what derivatives are and how to find them, we are going to move on to one of the last major topics of Calculus 1, antiderivatives. As the name suggests, an antiderivative is essentially the undoing of a derivative. For example, given some function f of x, its antiderivative, which is usually called big F of x, is the function that when you take its derivative will give you f of x. This may sound a little funky, but let's try it out with an example. Find the antiderivative of f of x is equal to 2x. In order to find the antiderivative, we need to think of 2x as being a derivative already. What function would give us 2x as its derivative? We know that from experience, x squared would. Because of the power rule, the derivative of x squared is 2x. Let's go ahead and write that big F of x is x squared. Antiderivatives are often as simple as doing a reversal of the power rule, but with one catch. We said that the derivative of x squared is 2x. But what about the derivative of x squared plus 1? That would also make 2x. The same goes for x squared plus 2, or x squared plus 3, or x squared plus or minus any constant. Because of the constant rule, the derivative of these second terms will always be 0, and the resulting derivative comes out to 2x. Because of this, when we take an antiderivative, we must add an arbitrary constant to the answer. That way we are covered for every possible one of these solutions. In our example, we would write that big F of x is equal to x squared plus c. That c is the arbitrary constant we need to protect our answer from missing solutions. Let's try another example. Find the antiderivative of g of x is equal to 5x to the fourth plus 7x. This problem, like the first, requires a reversal of the power rule. Since the power rule tells us that we can find a derivative by multiplying by the power of x and then reducing the exponent by 1, we are going to do the opposite of these things and in the opposite order. We need to add 1 to the exponent and then divide by the new power. For the first term, 5x to the fourth, we add 1 to the exponent, making 5x to the fifth. Then divide by the new power. Dividing by 5 gives us x to the fifth. For the second term, we increase the power by 1 to get 7x squared, then divide by the value of the new power to get 7x squared over 2. The antiderivative for this problem is then big G of x is equal to x to the fifth plus 7x squared over 2 plus c. Don't forget to add the constant. We can check this answer by taking the derivative. Using the power rule, the first term would go back to 5x to the fourth, the second term would go back to 7x, and the c would be 0. This is exactly what we started the problem with. Antiderivatives are more formally referred to as indefinite integrals. As we have talked about already, antiderivatives can be identified by their capital letter notation. However, moving forward, you'll probably come across integral notation more prominently. This means that instead of using the words find the antiderivative of this function, these indefinite integral problems are shortened by instead asking for the integral of that function with respect to x. The long S shape is what we call the integral symbol, while the letters dx specify that we are taking the integral with respect to the variable x. Every once in a while you may have a problem in terms of some other variable, but they can be solved in the same way. As we have discussed, the antiderivative or indefinite integral of some function f of x with respect to x is big F of x plus a constant c. If you haven't already, I want you to grab a pencil and some paper. I'm about to share with you the integrals of several common functions, and your familiarization with these will help you later on in your assignments. Ready? Let's start with some helpful trig integrals. First, the integral of sine of x is negative cosine of x plus c. This should feel familiar because we know that the derivative of negative cosine of x is sine of x. Likewise, the integral of cosine of x is familiar. We know it must be sine of x plus c. The next integral I want you to write down is the integral of secant squared of x, which is tangent x plus c. Next, the integral of cosecant squared of x is negative cotangent of x plus c. The integral of secant of x times tangent of x is secant of x plus a constant c. The last trig integral I have for you is the integral of cosecant of x times cotangent of x, which is negative cosecant of x plus c. Since the exponential function e to the x is its own derivative, it should come as no surprise that it is also its own integral. And finally, the integral of 1 over x is the natural log of x plus c. I know that this seems like a lot of information, but if you spend a few minutes writing each of these out a few times, you'll start to become familiar with them and memorization won't be far from reach. You can do this after you finish the video, or you can pause the video and do it now. Let's close by working through one more example. Determine the indefinite integral of h of x equals 8x cubed plus secant of x times tangent of x plus e to the x. The sum and difference rule told us that we can take the derivative of a function one term at a time. The same rule applies to integrals. We can simplify this expression by splitting up the terms into separate integrals. Even though this line is a little longer than the first, we can more easily see how to handle each part now. First, 8x cubed can be integrated by reversing the power rule. Let's add 1 to the exponent to get 8x to the fourth, then divide by the value of this new power to get 8x to the fourth over 4, which is equal to 2x to the fourth. We can always double check this by taking the derivative again. The derivative of 2x to the fourth is indeed 8x cubed. Don't forget to write the plus c. Since we have 3 integrals in this problem, I'm going to write a little 1 to indicate that this constant came from the first part. The next term, secant of x times tangent of x, is one that we discussed moments ago. Did you write it down? Its integral is secant of x plus a constant. I'll write a little 2 with this c to show that it came from the second integral. The third term should integrate quickly. As we said, the integral of e to the x is e to the x, so let's write that plus a third constant. Now let's clean this solution up just a little bit. Because c1, c2, and c3 are all constants, they're all just numbers, and their sum is just going to be another number. For that reason, we can combine the c's into one constant together. So the final answer for this problem is 2x to the fourth plus secant of x plus e to the x plus c. Remember, when integrating x to some power, you can reverse the power rule by adding 1 to the exponent and then dividing by the new power. Integrals of trig functions will require a little memorization, but you can get a good grip of them within just a few minutes of writing. The exponential function e to the x is unchanged by integration, and the integral of 1 over x is the natural log of x. And in all indefinite integral problems, it is critical to remember your plus c. I hope that this video was helpful. Thanks for watching and happy studying.